Okay, in section 3, we're going to be looking at maximums and minimums of functions. So just like they sound, maximum and minimums are just the highest and lowest point that has the largest or smallest y value in the entire function or just a small section of the function. So there are two types we'll look at. And for most of these, we will be looking at their graph. But don't forget, if you ever just have a equation, you can always graph it using our Desmos calculator that we've seen. So never forget that you can always make a graph of a function with that. So the first one we'll talk about is the global or absolute extrema. So the global or absolute extrema, and extrema is just a word that means the most extreme point, so highest or lowest. So the global extrema is the point where the y value is largest across the whole domain, and the minimum is just the opposite. It's the point where the y value is smallest across the whole domain. The most important thing about this is it's talking about whole domain, so you're looking at the entire function. So if we look at our two examples here, which are just two graphs that I made, we're trying to figure out what is the highest and lowest point across the whole domain. So this first graph, which kind of looks like some continuous function, let's look at for any global extrema. Let's first look for the global minimum or the absolute minimum, because that one's pretty clear. The lowest y value that this function takes is this negative 9.333. So it definitely has an absolute minimum. So the way we can write that, some people will just write the ordered pair, say the minimum is -2, negative 9.33. But one way it's written a lot is we say the absolute minimum is at x equal -2. So we basically say where the x value of the minimum is. And then we say of negative 9.33. So we say where it's occurring, and that would be at the -2 of the x, and what it is. Now, as far as the absolute max, let's look at this graph and try to see where is it the highest. Now, we kind of see at this point that it is kind of at the top of this little hill, but that's not the highest point, because as this graph continues up, it's going to continue up forever in this direction, in this direction. So the y value is going to keep going up unbounded. So what we would say is there's really no highest y value, because it's going to keep getting bigger and bigger and bigger. So we would just say there is no absolute maximum. So it does not have to have an absolute maximum or minimum. It just depends on the function. So let's look at the next one at the right, which is kind of a parabola that has a restricted domain. We can see that it starts here at -3, -5, goes to -2, 0, goes to the maximum of 0, 4, and then back down to 2, 0. So if I'm looking for the absolute minimum, it is a closed dot down here, so this is just my lowest point. So we have an absolute minimum at x equals -3 of, and that would be -5 because that's its y value. That's what made it a minimum. Now you kind of see this point is at the bottom of the right side of the parabola, but this point definitely has a smaller y value. So now if we look at the maximum, the max I think is pretty clear. It's at the top of this hill. It's at the 0, -4, because there are no y values above it. There's no graph above it. So this has an absolute or global max at x equals 0, and that's going to be of 4. So now that we've seen the absolute max or min, there are times where there are points that are at the highest, but it's not for the whole domain, just for a portion. And we call those local or relative maximums and minimums. So a local or relative maximum is going to be a point where the y value is largest across some interval of the function, but not the whole domain. So we're not going to look for the whole domain. So, and same thing for the minimum. It's the y value is the smallest, but not on the whole function. just on a specified part of the domain. So if we look at this function, we talked about this one on the previous page. We remember that this one had an absolute minimum of -2, -9.3. So there would be no, that can't be a local minimum as well. So when you look at this, do you see any points where they are the highest or lowest point in a certain region? And I actually see two of them, and that would be this one, because that's the highest in this little area, and it would be this one, which is the lowest in this little area. So the way we would write that is we'd say there is a local or relative max, and that's going to be at x equals 1 of 1.917. So that's the local max because it's kind of at the top of the hill. So maxes and mins are at the top and the bottom of these little hills. And so with that same logic, the local min is going to occur at the point x equals 2, and that's going to be of 1.333. So for both of these, it's the biggest or smallest y value in a smaller region of the graph. So let's look at our last example here. This last example is kind of a function that kind of goes up and down and up and down. So it's got some large y values, you can see, in the hundreds of thousands value, but the same logic applies. So first let's look for the local mins. So I'm looking for things at the bottom of the hill. So I can see one here, and then it kind of goes up, and then the next min I kind of see is here. Don't include that 0, 0 because the function doesn't change, it just kind of goes right through that 0, 0. And then it kind of goes up the hill, and then down here at the bottom. Now the 5 negative 136,825 is not a local minimum, that would be an absolute minimum. So I could list that out if I wanted to as well. So there are two local mins, and they happen at x equal -4, and that's going to be of 36,531.2. And there's another one that's going to happen at x equal 1 of -33,093.8. And then like what we said, there is an absolute minimum of at x equal 5 of -136,825. The one we don't include as well is this endpoint, even though that's kind of the highest point in the region. There's no point to the right of it. So that's just an endpoint. It's not really a max or a min. So now if we look at the maximums, the highest point now this one is the highest point in the whole domain. So it's different between an interval and a region. So that one is the absolute max. So the absolute max at x equal -6 of 203,644.8. And as far as local maxes, I see one here at the top of the hill here, and I see one here at the top of the hill here. So we're going to have a local max, the first one at x equal -2 of 99,913.6, and another one at x equal 3 of 302,088.6. So maxes and mins are very important, obviously, in lots of applications where you're trying to find the largest or smallest value in a domain or in a certain interval. So hopefully this is helpful. Please let me know if you have any questions.